All right, for today's lesson, you're going to need your workbook, and we're going to be in chapter 3.3, which starts on page 178. Okay, so 178. All right, today we're looking at functions still. So example 1 says, an auto assembly factory needs to purchase new welding robots. The factory manager has information on 2 different models of welding robots. The welding rates for each model are shown below. How do the welding rates for the 2 robots compare? So today we're going to look and compare functions that may be represented with a table, may be represented with a graph, or we might just get a unit rate. All right, so if we look at this first model, so the model T1000 over here, here is a list of how many minutes versus how many tasks it can complete welding. And we know from experience that usually this first column here is our X column, and this is our Y column. So they wanted to find the constant rate of change. And if you recall, the constant rate of change also refers to slope. So down below here, we see them using the slope equation. That's our y sub 2 minus y sub 1 over x sub 2 minus x sub 1. And we see this 52, which is represented here. That's our y sub 2, minus 20.8, that's our y sub 1, over 5, x sub 1, minus 2. I'm sorry, that was x sub 2, minus x sub 1. So they do the calculations, they get 31.2 over 3, they divide that, they get 10.4. So the constant rate of change for the model T1000 is 10.4, which means it can do 10.4 welding tasks per 1 minute. Okay, the model GNX 007 is represented over here by this graph. And they've actually gone ahead and put the step intervals in here. We see, so this probably reminds you a little bit of rise over run, another way to figure out our slope or our rate of change. So the rise we see is constant. We know it's constant because it's a straight line. But the rise is 11.2 over the run, 1. So the constant rate of change is 11.2. So for the GNX 007, that's 11.2, and I'll abbreviate, welding tasks per 1 minute. Okay, so we see that the model GNX 007 actually completes more welding tasks per minute than the model T1000. Okay, step 2, find the initial value for each robot. At 0 minutes, each robot has performed 0 tasks. So the initial value, if you guys recall, that is also known as our y-intercept. So if we look at the graph there, it's pretty easy to tell where the y-intercept is, where it's touching the y-axis. That's at 0. If you look at the table, though, it's not so easy to tell, but you can work your way backwards because you know at 2 minutes, it was at 20.8. So if I went back 2 minutes, to 1 minute, well, I would subtract 10.4. So 20.8 minus 10.4 is 10.4. So at 1 minute, it was at 10.4. If I go back another minute, 0, I would subtract another 10.4, and we'd see we'd be at 0. So both of the robots at 0 minutes did 0 welding tasks. Okay, down below, try it. It says, the welding rate of a third robot is represented by the equation T equals 10.8 W, where T represents the time in minutes and W represents the number of welding tasks. How does this rate compare to the other 2 robots? Type your answer, please. Okay, moving on to example 2. So example 2, we are comparing a linear and a nonlinear function. So again, linear just means it's going to be a straight line. Nonlinear, not straight. Okay, we've learned about functions though, and we can do the vertical line test, we can do mapping diagrams with them. So if I go ahead and look at this problem here, it says a square with the side length S is shown. The table shows the relationship between the side length and the perimeter as the side length increases. The graph shows the relationship between the side length and the area. How do the two relationships compare? So if you look at the table, you have a constant rate of change, plus 1, plus 1, plus 1, plus 1, over here, plus 4, all the way down. So because of that constant rate of change, that's key, constant rate of change means it's going to be linear. Okay, and we know this one is going to be a function. If we look over here, we see this is not a constant rate of change, but it does pass the vertical line test because, again, I can take an object, I can hold it anywhere on that graphed image, and it's never going to intersect that graph more than once. So it is a nonlinear function, okay? And a nonlinear function means it does not have a constant rate, okay? But they are both functions. Go down to example 3. It says two linear functions are represented below. Compare the properties of the two functions. So function A, the constant rate of change is 2, which we see represented there by the number in front of our x. So the constant rate of change, that's also our slope. The initial value in the back was -3, and you guys have been taught that it's also your y-intercept. So your initial value, where everything starts, that's your y-intercept. Okay, if we look over at function B, we see our initial value is 7 because that's where it touches the y-axis at. And then, so again, that's our y-intercept. And our constant rate of change is -1/2 because what they do is they just pick 2 points. They go to the corner of a box, goes down 1, to the right 2. And that's a negative slope, so that's constant rate of change of -1/2. Okay, let's go down to below to try it. Okay, look at function 1. Okay, look at function 2. And that is it for today.